You mentioned in your email that you don't have deep AI experience, but that's exactly why I wanted to talk to you, because everyone is focused on the, brain side, I mean the artificial intelligence, but no one is talking about the networking part. So according to me, if the networking is slow or too expensive, the AI is kind of useless. So I wanted to talk about that with you.
Yeah, sure.
So my first question would be a little generic. It will be on low latency. I uh, I feel that AI models need to move massive amounts of data very quickly. So from your experience in Azure, what is the biggest mistake people make when designing networks for high speed data?
Okay. So it depends what you're doing with AI, right? So if you are going to train a model that doesn't fit
Mhm,
in a GPU, like for example, the latest Blackwell GPU, the B200 has 180 gig, right?
mhm,
If you are running at FP8, that would be like 180, around 180. What is a gig? 10, 9, a billion parameters, right? So if you're running models with more parameters or models at higher resolutions, then you need two GPUs, and then the GPUs will need to talk to each other a lot, right? And
mhm.
the traditional network is not going to be enough, at least in the cloud, regardless, or even on premises, right? Regardless how you do that.
Right.
And then for that you need probably you need the interconnect capabilities of systems like the NVL72, right? That NVIDIA released. Now, if you are doing something else, such as fine tuning, maybe you are able to get away with it, right? Since you need less interaction between the GPUs, but still you need to load the model. Maybe you can distribute it across different layers, so you only need to load a tier and not the whole model, and maybe then you get away with a single GPU. If
Right.
you are inferencing, same thing, right? But still less requirements, because then every GPU is probably going to be able to do the inferencing independently, and then you don't need that much connectivity. Now, so depending on what you are doing, your requirements are going to be more or less stringent. If you have very stringent requirements, you cannot use standard Azure networking. You have to use something like InfiniBand. We have some virtual machines with InfiniBand in the backend. Um,
Uh-huh.
and on top of InfiniBand, you have RDMA, Random Direct Memory Access, which eliminates a lot of the latency that the TCP stack originates. If you Again, if you don't need that and you need Azure, and now I'm coming to your question, right? What mistakes customers usually do? For example, they spread their nodes across multiple availability zones. That's normally okay because you gain resiliency, but what you lose is latency between the nodes. Because if availability
Mhm.
zones are, say, 50 kilometers away from each other, I'm shooting a number, you would have a couple of you would have around 700 microseconds delay or something like that. So that might be acceptable or maybe not.
Yeah.
So that's between the nodes, and then you have as well the problem between the nodes and the storage, because when you shoot up one of the nodes, then it's going to have to go to the storage, and for inferencing retrieve the model. For training or fine tuning, it's going to retrieve not only the model but also the training data. So that's going to be a lot of storage access. So the second
Yeah.
mistake is, where do you put the storage, right? If you put the storage, same thing, if you put the storage in a different zone, or if you scale your storage the wrong way, for example, if you use Azure files, it's going to be slow. If you use something else, like a managed cluster, it's going to be fast. And there are many options in between. So those are, I would say, the two main mistakes I see people doing. So actually, it's either the node-to-node communication having too
Uh-huh.
much latency there, or the node-to-storage communication having too much latency there.
And what do you think are like one or two basic steps that they can take in order to improve that? I won't say it will give us the optimum solution, but what do you think should be one or two steps they should take in order to reduce the friction in this?
Yeah, so for node-to-node communication, you have a couple of options there. In Azure, you can use placement proximity groups in order to put
Mhm.
your VMs close to each other physically, right? You can even
Okay.
collocate VMs in the same node. Um, you can in the, for example, in the latest nodes that we have, you have nodes with two GPUs. So if your model fits in two GPUs, then you should run that on those. Um, if you are using Kubernetes for either training or inferencing, you should use some scheduling mechanism which is aware of the topology. So it's not going to schedule two pods running the same, one here, one there. It's going to put them
Mhm.
together, ideally even on the same node, right? So they can speak quickly there. That's for the compute placement. And then for the storage, it's essentially using a storage platform that gives you the best performance. For example, I would say I'm seeing quite a lot of traction in people using the local NVMe disks for data, because typically you don't have persistent data when you're training or inferencing, right? You just load the model, and
Mhm.
if your node dies, then it dies. You go to a different node, you load the node again, and you're good to go. So you can use the NVMe for those for storing the node. Sorry, for storing the model. So yeah, in Kubernetes, for example, you can use the NVMe using Azure Container Storage. In other platforms, if you're running VMs, you can use the NVMe directly. So yeah, I would say for the storage, the workaround would be choosing the right storage platform. Sorry if I'm talking too much. Just stop me if I.
No, no, absolutely. It's actually insightful for me. Uh, that actually makes sense. I mean, these two solutions might definitely reduce a lot of friction, and if they are just thinking of it right from the beginning in the workflow, I think it will make a lot of difference. Uh, my next question is on reliability. I mean, you have been an SRE manager. According to you, when a system breaks under a heavy load, is it usually a code problem or is it a networking bottleneck that people ignore?
Uh, could be both. I couldn't generalize, right? Could be both. A system can break either because of compute problems, because of
Mhm.
storage problems, because of networking problems. So depends on the system, right? For AI, for training and fine tuning, I think
Mhm.
I mean, again, I don't have a lot of experience, but what I've seen is mostly compute problems or storage problems. And for inferencing, what I've seen is networking problems. So inferencing is less taxing on the storage and compute, right? So then the problem moves to the next layer.
Got it. And there is no one area, one side you think you should lean more, uh, depending on the previous experience that you have.
I would lean towards compute and storage first.
Got it. Storage.
And that's also not only a technical question, but a financial one, right? These new GPUs, they are so expensive that you
Right.
want to have them utilized 100% all the time. So maybe your application is not breaking, but it's getting slower, and the GPU is a couple of minutes idle
Mhm.
during the time it's loading up the model, and that might be because of the network. So the network is not breaking your application, but it's making it more expensive because you need maybe to rent those expensive GPUs not for 3 hours, but for 6 hours. And then your costs are growing. So I
Right.
see it not only from a performance perspective, technical performance perspective, but also from a financial performance perspective.
Got it. Yeah. Cost governance is one topic that we should definitely look into. Okay. Next question is a little niche in terms of the post that I saw, the recent post you made on LinkedIn about the costs of VNet peering versus
Oh,
virtual
okay.
WN.
Yeah.
Yeah. So, I mean, you are involved in Kubernetes as companies move AI workloads into containers. What is the one thing about Kubernetes networking that always surprises people who are new to it?
Hmm. That's a good question. Um, so depends who, right? So if you ask traditional network folks, I would say that they are surprised that a lot of the concepts they knew, they don't apply anymore to Kubernetes.
Yeah.
Um, so in Kubernetes, everything can speak with everything else per default, right? And then traditional network admins then are missing, where are my VLANs? Where are my subnets? Where are my um, that I would say that's the first shock. The second one is possibly the way in which you need to work with gateways, both for ingress and egress, and
Mhm.
all of the YAML that you need to do, which you would do completely different in a completely different way in an on-premises network. So I'm thinking out loud. Sorry for babbling around. So I would say
No, that's okay.
I can summarize that as probably the declarative character of the Kubernetes network configuration, which is completely different to the imperative how you configure traditional networks in an imperative way, right? You go
True.
to the device and you do your stuff, but in Kubernetes you do just a CRD, a custom resource configuration, and then something happens. So maybe that's what I would say is the biggest shock I've seen administrators having.
Mm. What about the hidden costs? I mean, hidden networking cost. Does that actually kind of bankrupt their project when these AI company are trying to scale?
So are we still in the Kubernetes discussion or unrelated?
Oh, no, the Kubernetes one.
Okay, networking costs. So I would say that's generic, right? Not only for Kubernetes or AI, but in general,
Uh-huh.
people tend to underestimate networking costs, and that's part of why I wrote this post because I was part of that community underestimating the networking costs. And when you start
Mhm.
looking at them, then they can amount to a substantial portion of your Azure bill at the end of the day. Yeah, in AI, for AI, so for example, things I've been seeing people doing that increase their cost is excessive use of private endpoints. Um, many companies or some organizations mandate using private endpoints. However, that can increase the costs dramatically. A different
Mhm.
approach I've seen is what I wrote about in that post, like having a network architecture with many tiers and a lot of VNet peerings
Right.
between the tiers, and then that's going to increase the costs. Um, Sending too much traffic through firewalls. That might be applicable also to AI because I've seen customers placing firewalls between compute and storage, and that not only increases latency but also increases cost, right? And
Right.
then the last one I would say is logging. I've seen customers paying a lot of money for network logs, either logs coming from the firewall or logs coming from VNet flow logs. Like to give you an example, I saw one customer that he was paying 5 times more for his logs than for the actual firewall. So yeah,
All
I would
right.
say yes, both from a bandwidth and a logging perspective.
Perspective. Yeah. Right. And one question about the knowledge gap, basically. I mean, as I mentioned that we are working on this book, but it's very early right now. We want to just explore this area and domain and see what all how can we narrow it down and how can we actually try to create a very outline that will address the challenges. So according to you, if let's suppose I am a solutions architect building an AI app today, I don't understand networking. So according to you, what is the number one disaster that might happen to me? I mean, that is something that I should actually, keep my focus on.
Oh, uh, number one disaster is that one, your application is not going to work, or it's going to be extremely expensive
Mm.
because
I mean, I
the whole
understand the
system is going to be throttled down by the network, and then you're going to keep on throwing dollars to the machine.
I understand the expenses part here, but what do you think why the app might not work? What could be the initial problems?
For AI, and so it could be that your inferencing nodes take too long to load the models. Let's take
Uh-huh.
inferencing as example, which is probably the most frequent case, because with that many models out there, fewer and fewer companies feel the need for training their own models, right? So let's narrow down on inferencing. Let's assume that you have an application running with 3 nodes and doing inferencing in parallel. And let's assume that suddenly you have a demand peak, and then your application needs to scale from 3 to 6 nodes. Those additional
Mhm.
3 nodes are going to go to your storage where you have your model, and they are going to load the model. If it takes
Right.
them 1 minute, let's say, then that's going to work. If it takes them half an hour, by the time they are ready, your potential customers are already tired of waiting and have moved on to the next website.
Right.
So that's what I mean with not working, right? If your network is the inhibitor that prevents your application for handling the demand, you might lose
Mhm.
business.